All right. So we are going to be talking about graphing lines, graphing linear equations, right? Linear, it means lines. We're going to start by identifying the Cartesian plane. That is our X and Y axis. When you draw this graph, all right, so we have the standard grids here, but way too often I see people mess up with their drawings. So the first step you should always do is redraw your X and Y axes. This is the X axis. This is the Y axis. All right. And always start by drawing that. Notice that point there, 0, 0. Okay. It indicates where the center is, but it just never hurts to redraw this axis. So to start out with the quadrants, quadrant 1 right here, this is positive X values, positive Y values. Quadrant 2, negative X values, positive Y values. Quadrant 3 is negative X values and negative Y values. And quadrant 4 is negative Y values and positive X values. Gonna practice by plotting some points. Points are always identified in their coordinate pair X comma Y values. Don't confuse this with interval notation, right? The open interval from A to B. Ideally, in context, all right, you should always be able to identify the difference. One little note, we say if the point lies on an axis, all right, it does not fall into any quadrant. Oops. All right, so always start. Let's redraw our axes. So redraw the X and Y axes. And now let's plot some points. The point 4, comma 3. So this is X comma Y. So count 1, 2, 3, 4. 1, 2, 3, up. There's our point. All right. 4 over on X, 3 over on Y. Let's practice with a bunch more. All right. Negative 3, comma 5. So back 3. 1, 2, 3. Up 5. 1, 2, 3, 4, 5. Negative 4, negative 3. 1, 2, 3, 4. 1, 2, 3. Back 3, down 3. 2, negative 4. Over 2, down 4. All right, and I'm being very dramatic with my dots, notice. All right, the point 1, comma 5. Over 1, up 5. Point negative 2, comma 0. So back 2. All right, up 0. That means that falls right on the axis. That's what we're talking about. We got another one of those right here. All right, over 0, up 3. That one falls on the axis as well. Notice, all right, our red dot here, that's an x-intercept. All right, our y dot here, that's a y-intercept, right? So plotting points, that's stage 1. But graphing lines, that's where we really shine. All right. The most famous, without a doubt, is slope-intercept form. All right. Slope-intercept form of a line. Y equals mx plus b. You may recall that slope equals the rise over the run. That is the change in y values divided by the change in x values. B is the y-intercept, all right? And this will always be of the form 0, comma b. It is point pair form. It is super important. The y-intercept is not the value, okay? y equals 0? Because y equals 0, all right, is actually a line in itself. Then important, we have two special forms of a line to that end. All right. Y equals a number, X equals a number, a horizontal line and a vertical line. Notice, all right, the horizontal line, that is the form Y equals the number, and the slope is 0. For the vertical line, X equals a number, and the slope is undefined. All right, we're going to talk about that in a minute. So let's look at some examples. I want to identify the slope and y-intercept and graph the line y equals negative 3/8 x plus 6. When you identify, make sure you are deliberate here. Okay? The slope equals m, which is, in this case, negative 3/8. Way too often I see people say, oh, slope. Oh, there it is right there. That's not the slope. Okay? The slope is only one piece of this. Also, the slope is not negative 3/8 x. It is only the number. Be aware that that negative, right? Remember your fractions. That negative can go on the top or it can go on the bottom. All of these are equivalent. Most of the time, we kind of like this form here. We like to do the rise or the fall first and always run, all right, to the positive values. For the y-intercept, all right, that is always going to be the form 0, comma, all right, the b value, in this case, 6. Since we have this, when we go to graph, all right, okay, first of all, let's draw our coordinates in. First, always. Draw your x and y axis in. When you go to graph, slope intercept form, y equals mx plus b here. The best thing is to start with the y-intercept. Start with this point right here. So we just talked about graphing the point. So 0, comma 6. So over 0, up 6. 1, 2, 3, 4, 5, 6. So we start with that point right there. Then, all right, then graph, all right, the slope. Now, again, the middle form right here is kind of the best form, all right? So we're going to go down 3 and over 8 from this point. So we're at this point, all right, the y-intercept. From that point, now I go down 3 and over 8. Now, technically, in order to graph a line, you only need 2 points, but I highly encourage you do more than that. Do as many as you can for the entirety of the axis. So similarly, now I'm going to use the other one. I'm going to go back 8 and up 3. So up 3 and back 8. Now with 3 points, all right, it's way better, all right, to draw a line through 3 or more points than it is for just 2 points. Also, when you're graphing, notice that I'm kind of stretching the entire graph. That's how we want to make, all right, our graphs. What you don't want to do not. What I see a lot of times is people draw 2 points. Oh, and there's my graph. That is not the correct graph, all right? You don't have arrows on it. It doesn't stretch, all right, across the graph, all right? This is bad. Do not do this. All right? Make a good thorough graph, draw multiple points, all right, and stretch the entire range of the graph. It is just much, much better. All right, let's look at another one. Identify the slope and y-intercept and graph the line. 36 minus 12y equals 9x. We want slope-intercept form first, primarily. So let's get this in the correct form first. I'm going to get the 36 to the other side. And then divide both sides by negative 12. And then simplify that down. So negative 9/12 becomes negative 3/4 x. And negative 36 divided by negative 12 actually becomes plus 3. Once I have that, then I can identify the slope, which is negative 3/4, and the y-intercept, which is 0, 3. Again, point pair form. Once I have that, now I'm ready to graph. All right, so I'm going to draw my coordinates in. Always draw your axes in. Start with the y-intercept, so the point 0, 3. And then from that point, I'm going to count the slope, negative 3/4. And do that multiple times. Again, down 3/4. All right, that's basically good. And do it the same in the other direction. Up 3, back 4. Up 3, back 4. Again, lots of points. So when I draw my graph, all right, you don't need a ruler, all right, just sketching it in because I have the points there to make a nice graph, right, that expands the entirety of, oops, a nice graph here that expands the entirety of, all right, my coordinate system. Whoops, that was not the correct. Darn it. So nice drawn graph. All right, and notice slope and y-intercept very clearly defined. Okay, this equation is the slope-intercept form of a line. Y equals mx plus b. That is not the slope. That is not the y-intercept. Okay. That is just a form of a line. So make sure, notice the distinction, right, of identifying them versus just solving for the line. All right, so now notice here, all right, identify the slope and y-intercept and graph the line y equals 4. Ah, this is a special line. It's helpful to identify. We only have two. Y equals a number, all right, x equals a number. This is the special line specifically. This is a horizontal line. The slope of a horizontal line is 0, right? Notice, where's the m? Where's the x? They're not there. It's because 0 times x. I could write this equation in the form of 0x plus 4. The slope is 0. 0 times anything makes 0. That's why that part is not there. The y-intercept, though, that part is still there. That is the point 0, 4, right? The b part of the equation is still there. Let's draw our coordinate system in every time. This is your first step. All right, and then the point 0, 4. That's right here. This is a horizontal line. All right, there's no rise, no run, right? Go up 0 and over 5. Oh, put right there. Go up 0 and back. 8, whatever number. It's a horizontal line, which means when we go to draw it, it looks like this. All right. It is a special line. Similarly, we'll come back to this one. Because similarly, I want to make sure we can identify, all right, vertical lines. This is, again, a special line, and I can recognize it by its form. This one, all right, has other... Notice this is not in the form y equals mx plus b like the horizontal line. The y-intercept here does not exist. All right. Don't say no solution or a 0. Okay. It either does not exist or you could write not applicable NA. The slope here, all right, is undefined. Essentially, it's 1 divided by 0. All right. Let's draw that, and I'll explain that in just a minute. So, coordinate axes. This is x equals -5. That means at the point -5, 0, -5, comma 0. All right, for a vertical line, notice, right? I rise 1, and then I go over 0. So notice this fits exactly the rise over run concept, right? So I rise 1, go over 0. Rise 1, go over 0. 1 divided by 0, if you put that in your calculator will say air. All right, that's because this is undefined. All right, that terminology may spark something, all right, that is familiar to you. All right, let's go back, check this guy here. Once again, I want to identify the slope and y-intercept and graph the line. This is now a regular line, but it always starts with solving for y equals mx plus b. So I'm going to add 5x to both sides. Then, all right, divide by 3. All right, notice the slope is 5 over 3. The y-intercept here is going to be a little bit more challenging, all right, when we graph it. Now, clearly, it's the point 0, 4/3. When we go to graph this, that's going to be the challenge here. Because I always start by graphing the y-intercept, 0, 4/3. That is about right here, right? I don't know exactly where it is, about halfway in between 1 and 2. 4/3 is 1.33. That means it's about halfway between 1 and 2. It's not 1, it's not 2, it's halfway. Now the trick, when we count this, the slope is 5 over 3. That means rise 5 from this point. 1, 2, 3, 4, 5. Notice I'm in the middle, okay? Then I count over 3. 1, 2, 3. Notice I'm in the middle, all right? Up 5 over 3. Doing that the same direction down. 1, 2, 3, 4, 5. 1, 2, 3. Again. right? All these points, notice, right? They're halfway in between. I'm not on, all right, an exact box grid. That's what makes these, when you have fractions for your y-intercept, a challenge. But real numbers are never perfect. All right. Have said and will say many times, stats. All right. Real numbers are not clean numbers. Big long decimals. All right. Identify the slope, y-intercept, and graph this line. Again, first foremost, solve it for y equals mx plus b. If I have this, right, this is being multiplied by 7/5. Now I could divide it by 7/5, but much better multiply by the reciprocal 5/7 on both sides. Now this guy, right, slope, super easy to identify the value next to the x, 5/7. Notice I don't see the y-intercept. There is a hidden +0. The y-intercept here is actually the point 0, 0. This is a special line, sort of, in the sense that it crosses through the origin, the point 0, 0. The point 0, 0 is right here where the two axes cross. Then from there, just count it. Up 5 over 7. Same thing, down 5. Back 7. And then connect your dots. So, all right, when you see this form, right, y equals mx, that means that it's crossing through the origin. This is y equals mx plus b form. It's just b is 0. All right, so always pay attention to that for that. All right, and let's look at another one now in reverse. I want to find the slope-intercept form of a line with a slope of 3/7 and y-intercept 0, -5. Right? So this is why I want to make sure you can distinguish, all right, what is slope-intercept form and what is the slope and the intercept. Because we have the form y equals mx plus b. Well, we are told the slope m and b. That means y equals 3/7 x minus 5. Then I can graph this. All right, so 0, -5 for the y-intercept. And then from there, up 3 over 7. And down 3, back 7. And then we can connect our dots. So, right, this is slope-intercept form. This is the slope. This is the y-intercept. I cannot emphasize the difference between them enough. The pieces of slope-intercept become y equals mx plus b. But you have to make sure you can identify what piece, all right, belongs where. All right, we will stop it there, all right, for today. All right. Been a wonderful day, and there is a wonderful activity and home fun for you to take a look at. Have yourself a wonderful day. Thank you and goodbye.